All right, so this is 3.2b, mean value theorem. So let's talk about roles before we get into mean value theorem. Roles, what had to happen? I had to have two y values that were what? The same. So we're gonna say two y values that are the same. And then the function had to be continuous and differentiable. And so we just connect the dots with the continuous and differentiable function, right? And so what we do is if you want to get creative, you can make whatever you want there. However, it could just be a nice little parabola or whatever you want. However, in Rolle's theorem, what did we do? We took that derivative and we set it equal to what? Zero. And so what we actually found was these horizontal tangents right there. That's what we actually found in Rolle's. However, what was the slope between the y values? Zero. And so that's why we took a derivative and we set it equal to zero. And so today, they're not actually going to be the same y values. So now what we're going to do is we're going to take this slope of our secant line and we're going to have the slopes of the tangent line at least how many times? Once. At least once. All right. In this case, it was how much?
It was 2.
It was 2. However, it's going to be at least what? Once. All right. The mean value theorem. The function has to be what? Okay, so a lot of times it's abbreviated by MVT. That's our new gang sign. And so the function has to be continuous and differentiable. All right, so the function has to be continuous and differentiable. And then this is all it is. Our slope f prime of c is equal to f of b minus f of a over b minus a. And we can say this a lot of different ways. This is calculus slope. F prime of c is calculus slope, right? And what is f of b minus f of a over b minus a? That's algebra slope. So mean value theorem, all it is calculus slope is equal to algebra slope. The slope of my tangent line is equal to the slope of my secant line. Instantaneous velocity is equal to average velocity. So, if I were to rearrange this equation, I would multiply by b minus a, which is really your x values, because this is really like y2 minus y1 over x2 minus x1, yes? And so I'm multiplying by b minus a. And so now I'd have f prime of c times b minus a is equal to f of b minus f of a. Does anybody know what this actually is? This is point slope form of a line, exactly. So this is like your y minus y1 is equal to the slope, which is the derivative, times x minus x1. All right. And so let's do our first example. So given that f of x is equal to 5 minus 4 over x, we're going to find all the values c on the open interval 1 to 4 such that it applies mean value theorem. It fits mean value theorem. So a lot of the times I like to just do algebra slope first. And so what we do for algebra slope is we find f of 4 minus f of 1 over 4 minus 1. So it's just doing your algebra slope first. So I'm going to substitute in 4. So when I substitute in 4, what do I get?
4.
I get 4. And then I substitute in 1. So when I substitute in 1, what do we get? 1. That's convenient. So now we have 4 minus 1 over 4 minus 1. And so what do I have my slope equal? 1. So that's my algebra slope. Now I need to find my calculus slope. So now I need to do what? Take a derivative. How do I notate taking a derivative? F prime of x. So what's my derivative of 5? 0. How do I want to think of this negative 4 over x? Exactly. So now we bring down our negative 1 power. So negative 1 times this negative goes away. And so now it's what? 4 and then x to the what power? Negative second power. And so now I'm going to throw that to the basement just to make it a little easier. So now I'd have what? 4 over x squared. I have my algebra slope equals 1 and then my calculus slope is equal to 4 over x squared. So guess what I do now? I set them equal. And so now I'd have 4 over x squared, which is my calculus slope, equal to 1. And so now we're going to solve, multiply by x squared. So now I got 4 is equal to x squared. So what does x equal? 2 and -2. Which one do I not want? I don't want my -2. Why not? It's not on my interval. So if it's not on my interval, we don't care about it. All right? It's extraneous. All right? And so all we know is that x equals 2, I will have a slope at 1. And so f prime of 2 is equal to 1. You don't need that part. I'm just showing. If we look at our graph, what actually happened graphically is the slope of this secant line between these 2 points was 1. And then we found what x value, my slope was the same. And so my x value was at what? 2. And so that's what we just did.
That's really our C.
Find the equation of the tangent line of the graph of f of x equals 2x plus sine x plus 1 on 0, pi at the point which is the solution of the mean value theorem, confirmed by calculator.
Yeah, we probably won't. All right, so first we're going to do algebra slope. So what we're going to do is we're going to find f of pi minus f of 0 over pi minus 0. So we're going to substitute in pi, or if you like, you can plug them in, I guess. All right, and so we're gonna substitute in pi, and so we have 2 times pi, which is 2 pi. And then sine of pi, which is 0, and then plus 1. So f of pi is 2 pi plus 1. Minus, now we're going to substitute in 0. And so we'd have 2 times 0, which is sine of 0, 0 plus 1, which is 1. So f of 0 is 1 over pi minus 0, which is just pi. Guess what happens to my 1s? They cancel. Guess what happens to my pi's? They cancel. So I'm left with my algebra slope equaling 2. Awesome. So my algebra slope's equal to 2. What do I need to do now? Find my what? Calculus slope. How do we do that? Take a derivative. So how do I notate taking a derivative? F prime. Very nice. And so what's my derivative of 2x? 2. What's my derivative of sine? And then what's my derivative of 1? 0. So now I have calculus slope. So now what do I do with these two things? I set them equal. And so then I really get cosine x equaling what? 0. We're subtracting 2. And so now, when does cosine equal 0? At pi over 2 and 3 pi over 2. Now, do I want both of them? I don't want both of them. Why don't I want both of them? It's not on my interval. It's extraneous. All right? And so now I have my slope are the same at x equals pi over 2. And so now I need to do a point and a slope. Do I have either one? I kind of have my slope. What's f prime of pi over 2? 2. Okay, we already found it because we set them equal. All right, so f prime of pi over 2 is 2. If you wanted to, you could substitute it right here in, and guess what you get again? You get 2. However, we need to find our points. So we're going to find f of pi over 2. So we're going to take that, and we're going to substitute that back into our original. And so now we have 2 times pi over 2, which is how much? Pi. And then plus sine of pi over 2, which is 1 plus 1, which is 2. And so my y value is pi plus 2. And I think that's a fantastic number. All right. And so now we are ready for an equation of our tangent line. So now we'd have y is equal to, what's my slope? What's my slope? 2. And then times x minus my x value. What is my x value? Pi over 2. And then plus now my y value of pi plus 2. And so there is my equation of my tangent line on the interval 0 to pi over 2 that fits the mean value theorem.
2 stationary patrol cars equipped with radar are 5 miles apart on a highway, as shown in figure 3.14. As a truck passes the first patrol car, its speed is clocked at 55 miles per hour. 4 minutes later, when the truck passes the second patrol car, its speed is clocked at 50 miles per hour. Prove that the truck must have exceeded the speed limit of 55 miles per hour at some time during the 4 minutes.
All right, fantastic. All right, so the radar gun showed that the trucker only went 55 miles per hour and 50 miles per hour when he passed the 2 patrol officers, yes? So he was not speeding, right? However, this actually implies what? What kind of speed? That's not average velocity, but it's what? Instantaneous velocity. So when the radar gun happens, it's instantaneous velocity. He's like, who uses Waze? Me too. Do you slow down when you see that there's a, okay? It's wonderful. It's wonderful. However, this is our instantaneous velocity. And what we do know is we need to know that the average velocity is equal to my instantaneous velocity at least how many times? Once. And so what we're going to do is we're actually going to find its average velocity here. So what we're going to do first is, you see how it's minutes and then it's like miles per hour? So we're going to actually convert the 4 minutes. So we're going to go to chemistry a little bit. And so AP Chem Tutor is going to help me out. And so he likes these little boxes with unit analysis. And so if I need to convert these, it'd be 1 hour to 60 minutes. All right. And so my minutes cancel. And so what does 4 minutes actually convert to with hours? 4 over 60, which simplifies to 1 over 15 hours. All right. So anyway, I'm going to convert, instead of 4 minutes, it's going to be 1/15 hours. So my units match up. All right. And so what we're going to do is we're going to find average velocity. So we're going to find S of 1/15 minus S of 0 over 1/15 minus 0. And so how far did the trucker go after 4 minutes, or 1/15 of an hour? 5 miles. Minus, he started at 0, over 1/15. So how do I divide by 1/15? That is really multiplying by 15. And so what was the average speed of my trucker? 75 miles per hour. All right. So did he go over the speed limit?
Yeah.
Yes. And so his average velocity was 75 miles per hour. So by mean value theorem, he should get a ticket.
Ben rides a unicycle back and forth along a straight east-west track.
As he does.
The twice differentiable node function B models Ben's position on the track. The table below gives the values for B of t and Ben's velocity v of t. For 40 is less than or equal to t, and then greater than or equal to 60. Must there be a time t when Ben's velocity is 2 meters per second? Justify your answer.
All right, let's do it. So the things that we know is like, hey, here's my time 40 to 60, and here's my velocity. I got velocity at 2.5, and I got my velocity at 4.6. So does it fit intermediate value theorem? Is there a monkey in the middle? Is 2 in the middle of 2.5 and 4.6? No. So I can't actually use intermediate value theorem here. Is everybody following me? Now, if it said it was Ben's velocity 3 meters per second anytime in there, then could I actually do it?
Yeah.
Yes, then it would be intermediate value theorem. Does everybody follow? All right. However, it's not intermediate value theorem because 2 is not actually on that interval for my velocity. Everybody follow that? All right. And so what I need to do is I need to actually find the average velocity between 40 and 60. So what we're going to do is we're going to find my average velocity. So I'm going to find B of 60 minus B of 40 over 60 minus 40. So what is B of 60 in this case? 49. Minus, where's Ben at 40? 9. Over the 20 seconds in which Ben rode his unicycle. And so then, what is my average velocity of Ben on my unicycle? 2. And so here's the thing. So my velocity is actually equal to what? 2 at some point in time on the interval what? 40 to 60. All right. And so we need to actually explain it. And this is going to be our first time explaining it. We'll go over AP problems more later, but this is going to be our first one. So what needs to be proven for mean value theorem to exist? The function has to be what? Continuous. So the function is twice differentiable. All right. So B is differentiable. That's what it said. Therefore, it is what? Therefore, it's continuous. Because I need both in order for mean value theorem to exist. Therefore, it's continuous. And what do we know? Basically, restate what we did.
We found average velocity
And our B of 60 minus B of 40, our average velocity
was equal to 2 at some point.
was equal to 2. So we know that what?
It had to be equal to 2 at some point.
So v of t is equal to 2 at some time between what? Between 40 and 60 seconds. And then I always like your gang sign, even though they won't actually grade that part of it by mean value theorem.